सर यदि आप परमिशन दें तो शुरू किया जाए सर.
हाँ प्लीज.
Thanks sir. So sir, this is fourth batch of PARAKH program, that is Faculty Development Program of All India Council for Technical Education, and the program is being conducted by the Construction Industry Development Council, and this is the fourth batch in the continuation. In this program, we are covering the young faculties, assistant professor and associate professor of the civil, electrical, mechanical, electronics, and computer science engineering branches. The registration is around 400, and as we have allowed them to join through the YouTube channel, the live session participation will be around 200. So sir, with this background, I, Pawan Kumar Mishra, Director, Construction Industry Development Council, on behalf of Construction Industry Development Council and All India Council for Technical Education, welcome you in the fourth batch, third session of the Faculty Development Program. Dear participants, we are very privileged and honored to, to welcome today's session expert, Dr. Professor Niranjan Swarup, sir. I have shared his brief CV in our group, in our PARAKH group, but let me introduce him in brief. As we are aware that subsurface construction poses situation with complex problems to the development engineers, and trenchless techniques offers appropriate solutions, and the Indian Society for Trenchless Technology, INDSTT, is the apex organization to promote its application in India and SAARC region. A privilege to share that Professor Dr. Niranjan Swarup is the Director General of Indian Society for Trenchless Technology, INDSTT. Upon graduating in civil engineering from Regional Engineering College, Rourkela in 1987, he has been involved in various infrastructure development projects. The assignments handled by him have ranged from design, estimations, project planning, and execution. In addition to being a trenchless technologist, Professor Niranjan Swarup is also a formally trained arbitrator from Singapore International Arbitration Center and lead quality assessor under ICQ project of European Council. He is currently the board member of various professional bodies like Engineering Council of India, ECI, International Council of Consultants, ICC, and the Council for Application of Actuarial Science in risk management in construction and allied industries. He also represents India on the board of several international organizations like Asian Forum, Asian Concrete Construction Institute, International Council of Consultants. He is nominated member of several consultative committees like Bureau of Indian Standards, BIS, NDMC. He is the member secretary of several task forces and working groups for different bodies. The prominent of them are the Jawaharlal Nehru National Urban Renewal Mission, JNNURM, and the National Council for Vocational Training, NCVT, apart from others. Professor Niranjan Swarup is one of the prominent trenchless technologists recognized internationally and invited to speak at most of the important international trenchless events world over. He has to his credit several trenchless publications. He is the editor of No Dig India Journal and regularly contributes articles in the international trade and technical journals. He has also contributed substantially for the formation of code of practices for installation natural gas pipelines of BIS. In addition, he has developed code of practice for several trenchless techniques like directional drilling, horizontal earth boring, and pipe jacking, etc. He has edited and authored several textbooks and training manuals related to construction and trenchless technology. He has been responsible for initiating several trenchless courses titled Subsurface Utility Manager, Trenchless Pipeline Manager, and post-diploma courses in trenchless technology. Additionally, he is now initiating several courses on SSEM, pipe bursting, and other trenchless subjects. He is also involved in establishing trenchless technology research and education centers across India, The first one of them is now being initiated at Vidisha, Madhya Pradesh, titled National Habitat Center on Subsurface and Trenchless Technology under partial grant funding of AICTE. So, dear participants, really we are privileged to have Dr. Professor Niranjan Swarup as today's expert. Definitely, we will have understanding on the trenchless subsurface construction, and this area may be introduced in the academia for the better employment of the engineering students and for working in this area. This may be new area for the young faculties also. So, sir, with these words, I request to you to take the session. Now I am handing over session to you, sir. Sir, please, sir.
Dhanyavad. Thank you very much, Professor Mishra. Let me share my screen. All right. Is my screen visible, Dr. Mishra?
Yes, sir. It is just coming, sir. It is not at this moment, but it is being uploaded, sir.
No, I think from my side it is showing that it's shared. Are you able to see or not?
No, sir. It is not visible, sir.
Now is it there?
Sir, it is coming, sir. But again, it is not visible, sir.
Not visible?
Yes, sir.
Are we able to see now?
Again, same screen, sir. No.
Same thing?
Yes, sir.
Are you able to see now?
No, sir.
You're not.
Slide is not coming, sir.
Slide is not coming?
Yes, sir.
I don't know why.
नहीं सर, आया नहीं सर।
नहीं आ रहा है?
नहीं सर, उसी तरह का ब्लैंक स्क्रीन दिखा रहा है।
जी, एक सेकेंड, ऐसा क्यों हो रहा है? क्या अब आया?
It's working, sir. I can hear you.
नहीं आया?
नहीं,
Still not there?
नहीं सर। सर वो सर पहले उसे लैपटॉप पर ले लीजिए सर, फिर ओपन कर लीजिए, फिर शेयर कर दीजिए सर स्क्रीन। या
No visible, sir.
हाँ सर, अब आ रहा है सर, अब आ गया। नाउ इट इज विजिबल सर। सर सर प्लीज अनम्यूट कर लीजिए सर अपने को। सर
All right. Now it's
Yeah.
visible?
Yeah, sir, it is clear, but you start with first slide, sir.
Yeah, I know. I'm just going there. All right. We are talking subsurface construction. जमीन के नीचे कंस्ट्रक्शन करना, constructing below the ground surface. Now, all the engineers who are involved, and I'm speaking to faculty members, so obviously your business is to train boys and girls who can deliver such kind of structure for the nation. This is something which requires skills from almost all the branches of engineering. Though we call it construction, but we require spatial information, we require functional information, we require engineering of the structures, we require engineering of the materials and all those things. So all those put together is something which is essential for all of us. And if I put my might behind my student, he would be able to deliver the whole thing to the nation, and we will have a genuinely employable set of students or engineers. I hope all of you would agree with me, or all of you would feel that inculcating some of these information or some of these knowledges within our students is going to be quite helpful. So this is Subsurface Construction Faculty Development Program under ASLAP or PARAKH. This is presentation by myself, Dr. Niranjan Swarup, Director General, Indian Society for Trenchless Technology, India. Now, underground space is the future of urban settlements. We need appropriate vision to preserve it for our future generations. What we have today is not ours. It belongs to the future generation. We are just custodians of that subsurface space. If we spoil it, it will be spoiled for our next generation. Do we want to spoil it? And if we don't, let's look at how can we contain that. The presentation is in 6 sections: background, subsurface space, trenchless technology, subsurface constructions, academia initiative needs, and concluding remarks. I'm trying to convince you people to think about different requirements in the sector. It's an applied engineering field, and I'm sure that you'll find few of the applications of your engineering field useful in this particular segment. And collectively, we can create a whole system where a collaborative effort from your institution with many branches coming in can be helpful. Let's talk about the background. Trenchless technology is the family of subsurface construction techniques that help in remotely constructing, maintaining, or replacing subsurface utilities buried below the ground surface without excavating continuous trenches. In the national context, trenchless techniques have an extremely important role, both during construction as well as later during the operations, maintenance, replacement, and at the end of economic life. So basically, for the entire life cycle, I have the application of trenchless technology, and we need to understand, or we need to acclimatize our students to adopt those. As the urban area manager, it becomes imperative for engineers to have sufficient internal capabilities for construction, operations, maintenance, and replacement of buried utilities, both conventionally as well as through trenchless methods. Through this capacity, the nation would be able to get subsurface utility developed and managed efficiently and effectively. Prerequisite to achieve this capacity is to have proper vision of the application of trenchless technology in the development, maintenance, management of the subsurface utilities, as post-construction management and maintenance of buried utilities through conventional modes may become challenging and even impossible in certain situations. For capacity creation, we need our academic institutions to see ahead and include systems to cultivate students capable of rendering services for such engineering requirements. In this talk, we shall be looking at different aspects of subsurface construction and such vision attributes and modes to create national capabilities and put them to use in nation building. So let's move to the basic business. Now, what I'm talking about subsurface space, when I am creating something, the conventional method is to excavate a trench, place my structure or construct my structure and backfill it. That basically means I will be damaging my surface, I would be damaging the adjacent structures. Cost and duration of work will be related to the above ground structures and construction. More the denser area, longer the project. Deeper the utility, longer the project. More utilities buried in the ground, and you have to place your utilities along with them. More complications and longer the project or costly the project. Increasing mechanization due to deeper installations is becoming essential today. And if I am, let's say, bringing a major excavation equipment in a congested city, it becomes impossible to execute. But anyway, these are the conventional construction techniques that we face. Enhanced challenges in cut and cover methods, making bore tunneling or trenchless methods better option. And that is what I'm trying to convince all of you, that please think about it and let's see where my course or where my curriculum can help my boys, or the overall, the whole system, where they can apply it. When I'm talking about a conventional construction method, the problems are that underground space in the public right of way is heavily used. It's extensively pipes, cables, everything is buried there. And the traffic congestion is growing exponentially. Every day there would be new vehicles sold in India, and those vehicles are going to land up on the urban roads. The street pavement damages occur when we are talking about excavation. The cost of surface installation goes up every time, and direct and indirect business losses do come when we are excavating the thing. So this is when I'm creating a new utility or new infrastructure in any place, in urban areas or even in cross-country structures where we are bringing the constructing the pipelines connecting, let's say, Godavari to Jamnagar. There's a major pipeline connecting the Reliance refinery to Godavari catchment area. And all those require use trenchless technology in a big way. Now, I have created my utilities. Then what? Does my utility survive forever? No. This is a picture from Arvindo Marg last year. You can see the road caved in because of the failure of the pipeline, and the whole structure went down. Or this is from, I believe, Hyderabad or Vizag. No, Hyderabad, I think. There was a cave-in, and the vehicles and buses, they went in. This is a common feature in many of the urban areas. And this is something which is now, it has happened few times, because we are burying CNG or natural gas pipelines all around the city. City gas distribution networks are being created, and this kind of accidents, these are becoming reality now. Now, what happens actually when you are having a buried utility, it will start malfunctioning, and that malfunction will basically create cavities around the utility, and that cavity, when it becomes huge, the load on the surface will basically compact, and the road will cave in, or the structure will cave in, and maybe the roads and everything will go off. So what is needed, or what would be then the situation? The situation would be that we will have to go and repair or rectify all this. So please decide, do we want our subsurface infrastructure built to serve us, or do we continue serving them rather by creating or repairing those and the appurtenant infrastructure continuously? Naturally, as an engineer, I would never prefer the second part. I would like my infrastructure, subsurface infrastructure, to serve us. And that basically requires application of engineering. For creating new subsurface infrastructure, we need construction methodologies that reduce open cuts, surface damages, while building robust structures. For rehabilitating or repairing subsurface infrastructure, we need construction methodologies that help in using old subsurface alignment. When I have used a space, I need to retain that space for the usage of that particular pipeline. That way, any other pipeline can be laid at some other place. In case if I don't retain that space, so I'll be putting another pipe at another location, and two spaces would be wasted in subsurface region. Remember one thing, once you have laid the utility, the next level of utility will be coming below that, then below that, then below that. Because the younger the utility, deeper it has to go. And if that is happening, mind it, there are certain services, when we're talking about smart cities or even normal cities, there are certain services where the levels are frozen because you have discharge locations frozen. So it becomes imperative that you retain the same location. So anyway, so basically I need the methodologies that help in using the old alignments, reducing open cuts while retaining or enhancing the infrastructure quality. Key to both of these are smallest footprint. And that is what we achieved through Trenchless technology. So let's discuss Trenchless technology. It is a set of techniques for the remote installation, rehabilitation, and repair of utilities, pipelines, and small tunnels linked by their lack of need for digging a continuous trench for the installation of new structure or their repair. So basically what I do is I create a cavity in the ground, or I maintain a cavity in the ground, and by creating that cavity, I render certain services to the consumer or to the catchment area, the habitants. So basically, when I'm talking about Trenchless technology, it comprises of 4 branches or 4 fields. One is the new installation, second is the rehabilitation, third is the replacement, and then since we are working in the ground without excavating continuous trenches, we need to see through the ground. So that is the 4th segment, where I'm seeing through the ground using certain engineering inputs. And that particular application are basically the 4 primary legs of Trenchless technology, which we apply. Now let's look at these legs one by one. When I'm talking about new installation techniques, what I mean to say is I'm creating a cavity in the ground. So I can do by shifting the soil sideways. I can cut the soil and actually remove that, or I can do fluid assisted boring, where a fluid or a mechanical device cuts and breaks the ground, and a excavated material is removed by the circulating fluid. So these are primarily 3 major cavity creating methodologies, and that understanding will help us to see where we can apply the basic engineering in this. So now we created the cavity. Now the cavity on its own will not survive. we need to provide some wall, and that wall is basically the pipe or the structure which we are placing there. So this pipe or structure would be deteriorating over a period of time. I need to arrest its failure process. So what would I do? I would basically plug the leaks in the beginning, as we see that if the leaks are there, it will permit the soil to cave in or get inside the pipe, and it will in turn damage the whole surface. So I will plug the leak, or the second stage of the damage would be where I would be inserting a leak-proof membrane which prevents the fluid to flow in, but does not give any structural strength to my pipe or my structure. The third one, where my structure has become completely weak, I would be inserting a load-bearing liner which will take the load and retain the whole space. So these are the three primary rehabilitation modes on which different methodologies are created and applied. There are many methodologies and methods in all of these systems, and they are developed to suit a specific need or requirement. If I'm talking about any place or any utility which has alignment and grade control, there are specific equipment which have to be used, there are specific methodologies which have to be used so that the structures are robust and usable. Now, I did rehabilitation. The second stage would be, or rather the last stage would be, the utility is unable to survive, and it would become more practical if I replace the liner. How do I replace that? I burst the corroded liner from inside. I insert a cone, and that cone basically has a larger diameter than the existing pipe. So it crushes the pipe, and the pipe is pushed out, and the cavity or the space which is created behind it, the cavity space created there is filled up by the pipe being pulled in. Or I can run a knife through it. The knife will cut the pipe, and naturally behind it, the new pipe will be pulled in. This is done generally for the metallic pipes which are ductile, and cracking them is not easy. Or I can do imploding. I can practically break the pipe and remove the material axially. So these are the three primary pipe replacement methodology by which I can remove a buried pipe and place a new pipe therein and use it continuously. Now, then comes seeing through the ground. Seeing through the ground means under remote controlled operation, the subsurface information has to be gathered. If it is not available, there is a chance that we may go and damage or destroy the existing structures. And to avoid that, what we require is, we require the status of the buried pipeline, we require the status of the geophysical facts in the ground, and we require the pipeline condition information. Now, status of the buried pipeline means that you would know, or that you find out at what location at XYZ coordinates the pipeline structure or the structure is existing. That is done by applying certain geophysical methodologies, and in addition to that, certain protocols are there which are called subsurface utility engineering. So those protocols help you to identify and designate a specific pipe where it is buried, and based on that information, the works are done. Then comes the geophysical information, where you need to know what is the soil strata, what is the quality of soil, based on which you will select the equipment, you will select the fluids or cutting liquids, you will select the other complements like downhole tools and everything. So for that, you require geophysical information, which is done conventional as well as through different geophysical methods like seismic refraction, ground penetration radar, seismic reflection, electrical tomography. All those things are conducted to know what is the status of the soil. Then comes condition assessment. Here what you do is you will be running a robot inside the pipeline and know where are the pipes cracking. And this will help you to identify the locations where the leakages is going to happen or is happening. So application of trenchless techniques must be done on the basis of information gathered from these three segments. The first two refer to the new installation. The third one refers to the pipeline condition assessment. So this is third one refers to the rehabilitation and replacement of the pipelines. So in isolation or in combination, these methodologies are applied to see through the ground, or subsurface survey is done. Now, the implications are, as I indicated, the deeper you go, the cost goes up, the time goes up, your damages go up, all those things when you're going for open cut excavation. But when you are using trenchless technology, your entry location will be defined, your exit location will be defined. This, if it defined, the other sections are not being excavated. So your cost is not very connected with the existing depth. You can lay the pipe at one depth, you can lay the pipe at another depth, and you will probably end up with the same cost and same timeline. Now, remember one thing, when we are talking about trenchless technology, we are avoiding all the buried utilities. We would know it by running the subsurface utility engineering protocol, and that protocol will tell us that the pipelines or cables or the structures are buried here, and they will basically define where we can lay our existing new pipes or new structures. So that is helpful if I'm going for trenchless technology. If I don't go for it, I need to excavate everything, expose everything, risk them, and damages could occur to them. Then comes if I'm building large scale structures in future. Let's say you are building one tunnel in the city, and then tomorrow you want to build another tunnel below that. There would be challenges, because when this second tunnel is being built at that level, the first tunnel can be destroyed or damaged. So this also is avoided by trenchless technology. Then comes social cost impact. If you're applying trenchless technology, you are not damaging anything on the surface for the most of the project length. And if that is there, the social cost is the least. If you are excavating a trench on the road, naturally there will be diversions, there will be losses of business, there will be gases and excavated material, like parali burning brings Delhi with a very bad gas chamber situation. So all those can be avoided if you go for trenchless technology. And then you can change the utility systems to accommodate new methods, like especially when you're building the smart cities, you require sensors to be placed, you require Internet of Things, and those inputs are very easily achieved by trenchless technology application. Most of the smart cities are utilizing trenchless technology, and I'm trying to convince all of you that please train your students in these fields so that the boys and girls get engagement with those smart city SPVs or their contractors. And mind it, this business is going to survive till the smart city is going to survive. So obviously it's a long-term goal. So let's look at subsurface constructions, the engineering part. The subsurface works are executed in a non-homogeneous media full of challenges. Possibilities of failures and accidental damages to existing subsurface structures are a very close reality if trenchless application is erroneous. Errors possibly could be the erroneous subsurface information, unsuitable technique, unmatched capacity equipment, poorly skilled operators, or poor quality material or consumables. For a successful project, one needs to remove such errors, and that is where the role of the professor comes in. Let's look at briefly the life cycle of a utility. You plan and design, you construct, you inspect and maintain, you rehabilitate or renew, and then you replace or remove. So if I look at that, it will be new installation, rehabilitation and replacement, seeing through the ground, and life cycle. Data management are 4 pillars on which this whole utility life cycle survives. When you're planning, you plan the route, do the site investigation, visualize the site model, design for the construction, design for the life cycle. When you are constructing, it's construction process, updating the site model which you made in the previous stage, avoid damages, create construction records. And those should be ABD, as built drawings. Then comes inspection and maintenance, where the data is managed, the ABDs, the quality of material, the joints and everything are defined. You have the low-cost sensors installed. You have smart materials which work based on the need And then there's a performance feedback that comes in that, okay, this pipeline is going to fail over a period of 2 years. So get your things rectified now. Now that kind of proactive approach is something which is quite essential for smart cities. And obviously our engineers have to be trained accordingly. Then comes rehabilitation renewal. There, the deterioration prediction is done. You do the asset management, select a specific method, how you are going to rectify the failures or the rehabilitation jobs, and then update the records, because the moment you strengthen it, its quality would go up. And the moment the quality goes up, it would supersede your construction records, which you made made in the second stage. When the utility is at the end of its life, you do the management like finding the utilities, because you would be aware that if you go around any urban area, the utilities which are built 10 years back, 20 years back are already buried below the ground and more structures have been built over it. Finding those utilities itself is a challenge. So anyway, finding utilities, design for replacement, and updating the record. So these are all part of the activities which somebody who is managing subsurface infrastructure or constructing and managing subsurface infrastructure has to perform. Please think about your line of business. If you are a computer engineer or you are teaching somebody computer, there are codes you can write for any of these activities. There are systems you can develop for data management, data gathering, designation. There are, let's say, CCTV camera is there. The CCTV camera, once it is running inside, let's say in a city like Delhi, the pipelines which have been created here are more than 9,000 kilometers if I add everything in one place. So now 9,000 kilometers of data is some huge data which has to be managed or understood, that how do we manage it, that the failures are avoided at the latest, at any stage of its operation. So all those things do come in. You think of your branch and there is a major role of that particular branch in this field. Now, what is the engineering process generally applied? You define the requirement, generate alternative solutions, evaluate the alternatives and select the most suitable solution, perform the detailed design, promote the design so that it is accepted or approved, construct and test, performance evaluation is done, and then finally conclusion reporting. So this is the basic engineering process of this life cycle, what we are talking. Now, what happens here is there are geotechnical issues which cloud the subsurface construction. It is a challenging business, and that is why we require educated boys and girls who can understand the primary challenges. The jobs are uncertain. If you are aware, in Kolkata, in Bahu Bazar, the Kolkata Metro was creating, laying the line, and the machine, which was about 6 meter diameter, punctured a water body, and the water flooded the whole tunnel. And it was a catastrophic problem. So all those things give uncertainty to the business, and that is a very expected thing. And here comes the decision-making skills of our engineers, who can really understand that if they are applying something, what could be the outcome. The conditions which have been defined could change, because that water body, in the example I gave you, that water body was not known. In the contract, they thought that it's a solid soil, and they just went on tunneling, and then they got the water. You need appropriate expertise and timing, because these are the processes where you are creating utilities below the ground. You have to do a non-stop working. The moment you stop it, the project will go into suspension, and if the project stops, inertia is going to spoil the whole process. So you have to have proper expertise in the whole process, number one, and then run it in a way that the project is successfully concluded. There are contractual conditions which boys and girls have to understand, that they have to be aware of those requirements. And then the monies available for investigations are generally not available. And that basically means there are challenges and some anticipation or some kind of guesswork is applied. The more systematic guesswork will yield safer projects. And that is where we have to educate our boys and girls in a better manner. When I'm talking about technology issues, the technologies mean we are talking about constructing or excavating remotely. So this is a more remote operation and the challenges are substantial. Imagine if you are building a pipeline which is 2 kilometers long and you are drilling it from one end. So imagine a drill rod rotating, which is 2 kilometers long drill rod. The challenges or the shaking possible there. So those issues basically cloud the application. There are less direct observation of the ground conditions. You would not know what is really situation in the ground inside because you are just making educated guesses. The life cycle approach to the design and management of underground structure is something which has to be inculcated in our boys and girls. And then the greater use of see-ahead technologies is the essence of whole operation. Subsurface construction and trenchless. Trenchless technology applications are remotely operated, smart construction processes that are extremely useful for creating, maintaining, and managing subsurface utilities without excavating continuous trenches or without continuous excavations. Through this feature, surface and subsurface infrastructure destruction in urban areas can be avoided during construction. In addition, positioning processes and systems of these techniques help in creating correct as-built database of the buried utilities, providing valuable inputs for future maintenance works of the subsurface utilities. That Internet of Things, which I'm speaking for smart cities, is something which you can create from this information, or it is created from this information. Utilities like water supply, drainage, power and telecom lines, petrochemical and gas transmission and distribution network are commonly buried below the ground surface. Historically, these have been laid by conventional open-cut processes. With enhanced density of subsurface networks, trenchless techniques are becoming preferred construction process because you cannot go on excavating open cuts, open trenches and laying your utilities forever. There will be a limitation when your existing pipelines will come. You can look at the brochure of one of the programs that we conducted. You can see these are the electrical poles on the road and these are the utilities buried below the ground. Now, if you have to lay another utility below it, it will be a bigger challenge. So anyway, this is something which has to be addressed. Works, however, are becoming difficult with the passage of time and growth of subsurface utility densities. Trenchless project failures are culmination of several issues and need is to address those adequately. Now, let's look at the anatomy of failure. The failure can happen if I select an inadequate or improper technique. There are several techniques, several trenchless techniques, and you can choose any of them. But then if it is not suitable, you will end up in a failure. Inadequate site and or soil investigations. Inaccurate subsurface interpretation. You will be running, let's say, ground penetrating radar. Now, this radar sends radio frequency signals down, which gets reflected, and that this passage is measured into nanoseconds or whatever may be the units. Now, this measurement will depend on, or rather, this time lag will depend on the dielectric constant or different characteristics of your soil, and that will basically alter the depth measured, or that will give you erroneous depth. So, subsurface interpretation is something which has to be very clear, and the boys and girls have to know that. Unforeseen ground conditions are there because, as I explained previously as well, another possibility is that while you are creating a cavity, you go and get inside the existing pipeline. There has been a case during the Commonwealth Game in New Delhi in which one pipeline on one road was collapsing one by one. In 1 month, it collapsed 10 times because what happened was the people who were laying HDD pipes, HDD lines, they were simply drilling through the sewer line and creating a hole, putting their cables and going away. And later, when the monsoon came, because of the water pressure, one location, the pipeline collapsed, poop, 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 poop. This went on happening. So that is something which basically ended up in excavating, like the utility had to be excavated and repaired everywhere. Usage of under capacity equipment or equipment breakdown. These are something which we need to cultivate our boys and girls, that they have to understand the project requirement and based on that select the proper equipment. Inadequate temporary works. When I'm doing my project work, there are primary needs of temporary works, and if I don't do properly, the project can fail. Installation of inappropriate or weak materials. It's very understandable statement. Failure to adhere to the work or material specifications. That is, there are specifications which have been created for trenchless technology. INDSTT has published those. I've been the secretary for the code formation committee, and we have published 7 codes. We expect to release another code in April when we are going to hold the Nordic India conference on 8th April. So that will be the 8th code coming in. So all those are there. And then finally, inappropriate or bad workmanship. If the proper work is not done, you allow bad operators or you allow unskilled operators to run the machine, you are going to end up in troubled project. Mind it, a tunnel boring machine, a TBM requires specialists or operators who are having master's degree in engineering. MTechs are generally employed for running the TBMs. The BTechs generally are taken in for installing or rather smaller machines. So that is what is the level of information and level of knowledge which is needed. But unfortunately, as the engineering colleges are not producing such kind of professionals, either the untrained people from the ground are taken in, or people from overseas, they come and charge us huge sums of monies for their services rendered to the nation. And that is why we are trying to convince all of you that please educate our boys and girls so that we can have our own capacity to construct, maintain, manage the subsurface utilities successfully. This is the anatomy of failure in trenchless. Failure to complete the installation, failures in job site safety matters, damage to environmental, natural or other above ground resources, surface collapse or heaves, hydrofracture or inadvertent drilling fluid and effluent returns, damaging other utilities. So this is specifically for trenchless. And what are the reasons behind it? When I'm drilling, there is a fluid which I'm pumping in, and that the fluid which is lost. The fluid will not be bringing anything back, and the pipeline will collapse. There can be obstructions in front of it. There can be hydrolock where the pressures are getting created. So we need to design the fluid in a way that hydrolocks are not created. Line and grade failures are there. Let's say I have to create a pipeline at a specific depth and an alignment. I do apply a machine which is not capable to do that. Result would be a pipeline created which would be like this, and it won't drain off anything if you want to have a gravity flow pipeline. You can have borehole or cavity collapse. You can have pipe collapse. You can have drill pipe, downhole tooling failure. So all those things lead to more failures. Now, what are the essentialities of trenchless projects? Minimum horizontal and vertical clearances are needed. When I'm creating a hole, there is a possibility of the equipment going and cutting and damaging something which is coming within its influence zone. So there has to be certain clearances for a specific type of machine. That has to be understood by the operator, and naturally he has to be made aware by the faculty members who are training him. The road setbacks, existing surface features and existing underground utilities, these have to be known. The product pipe and associated tooling diameter requirements have to be understood. Alignment geometry for the ground profile has to be known. Trenchless equipment requirements for the geotechnical conditions need to be understood, and based on that understanding, the equipment has to be sourced or applied at the site. Equipment and material handling requirements have to be defined, and material strengths, capabilities, and joining methods. All these things require different aspects or different understanding of various engineering fields. We have to have that understanding in our boys and girls. The critical input for Trenchless project is Trenchless attributes, required attribute of executing agency, technology selection, execution plans, third-party inspection, challenges in new installations, liners, and pipe bursting. So these are the critical inputs which are essential, which have to be understood if my project has to succeed. Attribute of Trenchless means these are basically specialized in nature. These are not run-of-the-mill works. The technique selection has to be very, very clear and precise so that you don't end up creating a utility, or rather a poorly constructed utility or poorly repaired utility. Operator skills are an essential part of it, where your role comes in. You have to be teaching your boys and girls, how do I do the planning, how do I do the design, how do I do the execution, how do I do the reporting, and how do I do the as-built drawing preparation. So all those things do come in. You have to have suitable equipment meeting the project and site requirements. The installed materials have to be properly selected. The technique-related limitations are always there, and every limitation has to be understood, and based on that, decision have to be taken. Proper subsurface data requirement is one of the essentiality. And then finally, impact of surrounding structures also has a more effect. Like let's say you are working close to a retaining wall. There are possibilities that this particular work will make your job challenging. So all those things have to be understood by the boys and girls. When I'm talking about executing agency, the agency has to have the knowledge and experience to execute such projects, appropriate equipment capable to execute such projects, adequately trained and certified operators, adequate capabilities for subsurface investigation or an access to those. So unless until this executing agency has these proficiencies, it will not be able to deliver the project to for the use of the owner. Now, if I'm talking about project management, the control considerations include planning, permitting and easements. That is, how do I put my working equipment, and how do I have people vacating the area, or the surface vacation, subsurface area vacations, risk identification, alignment design, pipe stress criteria, directional accuracies and tolerances, and product pipe considerations. So if I'm controlling my project, these are the inputs I would be applying. And obviously the engineer or the student learning from us have to have these understandings. When I'm talking about planning, planning means I need to understand the overall project requirement, product pipe, diameter and material, length and depth of the crossing, work site and access conditions, feasibility of trenchless measure and equipment usage. Then comes pre-planning and mapping, where I will do the computerized alignment planning. How am I going to lay my structure? When I'm talking about job site safety, it depends on the operator skills, safety, health and environment issues, job site inspection and briefings, overhead structures, underground structures and appurtenances, trenchless and allied equipment safety, and electrical strikes. Because we are working below the ground, there are chances that my machine can go and hit a power cable or a gas line or anything. So those are the job site safety issues which my boys and girls have to know. Directions for project planning and execution. The basic trenchless project consideration have to be inculcated within them. The pipe path alignment considerations have to be told. Directional accuracy and tolerances evaluation, they should know. The product pipe considerations, what are to be used, that they should know. The stress considerations they should know, and as-built drawing considerations are another essentiality. When I'm talking about performance standard of the equipment operations, safety during the work, working drawings and sketches, compliant execution, whatever we have drawn, the installation or construction has to follow that particular methodology and the drawings and the directions. Appropriate use of equipment and tooling, machine operating procedures and sequencing, meeting the minimum qualifying competency standards for the operators. So these standards are there. They are available on the INDSTD website. Do have a visit on the INDSTD website. That is indsTD.com. Have a look at the competency standards and see if we are able to cultivate these things in our students or not. And if we are not, let's try to do it. Let's create a group of people who are prepared for trenchless project execution. Now, what I ask from you, this is the initiative I expect from the professors. First of all, understand the need. The national need and future trends are urban flooding and linked disasters are now almost quite common. You see the area, many cities, most of the cities would have in the monsoons, areas being flooded, houses being inundated, losses are there. That has to be rectified. Now, it is not being rectified because the drainage structures are not performing properly. We need to have those drainage structures created. And who creates them? The trenchless technologists, because you're sitting in an urban area. Operation and maintenance of existing infrastructure assets. In the last 20 years, in today's price line, we have invested close to about 4 lakh crore rupees, 20-25 years. So it's basically 100 lakh crore rupees money, 100 lakh crore rupees worth infrastructure has been created. And not less than 20%, that is 20 lakh crore worth of pipelines and subsurface structure has been created. Mind it, its maintenance, its operation requires huge sums and huge engineering inputs. This is a huge national need. We invest close to about 4 lakh crore rupees per year. If I just add the cost of the money, the value of the infrastructure which we have created, we need to spend more money in its maintenance itself. So that is the operation and maintenance of existing infrastructure assets. Then comes smart city, utility operations and management. There are 100 smart cities under development and at different stages of completion. Obviously, we require boys and girls capable to deliver services, capable to know that my structure is going to fail after so many days or months or years. And what are the proactive rehabilitation needs that has to be I have to do. Then comes city gas distribution network. Almost most of the major cities, and I'm talking about even not only A grade, B grade, C grade, D grade cities, everywhere there is a huge gas distribution network creation is right now ongoing. And this basically means we require professionals to create, maintain, manage those utilities. Then mind it, it's not a simple job. It requires real engineering understanding. Enhance subsurface utility networks to cater rising urban demands. The rural population is moving into urban areas and the demand is growing. Let's say if I'm supplying 70 liters per head per day water and my population is say 10 lakh people in a city. Tomorrow if this population grows to 15 lakh, the additional 5 lakh people will require additional 50% of the current supply. Now if this water comes in the housing system, this water also gets drained off from the housing systems. Where does it go? It goes through the network which has been created. Now, the network which was created for 1 lakh people or 10 lakh people. Now, if it is 15 lakh people, the additional 5 lakh people's discharge is going to spoil the whole structure. So, there is enhanced subsurface utility networks required to cater these rising demands. Major transportation and material transfer tunnels are now being made across the nation, and everywhere you require professionals to work on those jobs. We don't train our boys or girls, we get untrained people to work on those projects. And if that happens, it's loss of our own money, loss of our own resources, and loss of our own subsurface space. Then comes international market. Most of the developing nations are now applying trenchless technology, and the boys and girls who were trained under INDSTD, many of them are now serving international markets. I would propose to enhance this overseas job getting situation. Please think about your students if they are able to get some employment in Philippines, some employment in Saudi, some employment in Africa, South Africa and all, they would be having a very good life. Mind it, sometime back or few years back, we used to get overseas operators and specialists to come and work in India. So we have cultivated people, but we want to make it institutionalized, and that is what is my proposition. Improvement and extension in more developed countries is one direction, and basic systems creation in the less developed countries. So these are the international applications. Now, when I'm talking about see-ahead technologies, this is what I meant. You have GIS and GPS communication. You have different kind of information which is being gathered, which is being maintained, and IoT is created. There are sensors and data technologies for rehabilitation. These are all available, and if you search, you will be finding many things available which you can teach or train your students. Now, what is going to happen, or what is the impact of those demands and needs? The increased market for underground construction is getting developed. Increased imperative for professionals to be more involved in underground space user issues, and new geo-related research and technology development opportunities are coming up, which, please appreciate, has to be addressed by people like you. Say you are teaching or you are working in a city which is C level city or B level city. Now, all utility owners, and let's say PWD or municipal corporation or whatever, they would not have the possibility of accessing, let's say, IITs for design. A common feature has been for metros, the courts have been giving orders that, okay, you go and talk to this IIT and get the design done. Why can't your college do that design? And if your college can do that design, naturally, you would be teaching students, you would be earning resources, you would be earning monies for the institution as well as for yourself. You'll be creating infrastructure for your engineering college, and that infrastructure will naturally help in creating better professionals in the market. So the way forward is, subsurface construction requires adequate application of engineering inputs. Each subsurface project is different and needs to be planned, designed, and executed to suit the site requirements. Some of the important engineering inputs include specifications, contract conditions, schedule of rates, standard operating procedures, method statements, subsurface utility engineering codes, project supervision, code of practice for directional drilling, operator competency standards, and all. INDSCT has published these books and manuals, and also several reference manuals. We have published about 40 odd different editions, and they can be applied. My invitation to all of you is that please have a look at those proper project execution. Have a look at our website. There are several INDSCT training programs to overcome different challenges and cultivate operator or engineer skills. Practicing engineering professionals can enhance their skills and that way enhance their prospects. Students and entry-level engineers could benefit immensely by learning the technology nuances. The utility system owners can get help greatly in adoption of the technologies by developing their own capacities with the help of INDSCT and your colleges. If you are living in a city, any city, whichever municipal authority is working there, contact them, get in touch with them, and assist them in creating, maintaining, and managing their utilities. It's a win-win situation for everybody, and we will be holding your hand to go ahead. To initiate the actions at the grassroots, we need to develop systems for creating professionals having sufficient understanding of trenchless systems. Engineering institutes or institutions need to become a part of this capacity creation process. That could be done through interacting with the local civic agencies and ULBs, urban local bodies, and providing them advisory assistances. Students could be deployed on the project for onward development of capabilities in them. For addressing technical capability gaps, such institution could work with us by establishing chapters at institutional level. What we can provide you is INDSCT publications, other trenchless publications from the world over, our inputs, our member network who can work with you, Our training programs, other trenchless training programs from world over, we have a global network, and on that, several training programs are conducted. You have that access. We do conduct Nordic India shows. The next one, or the closest one, is happening Nordic India Conference, which is on 8th April. I would invite all of you to consider coming and participating herein, so that you would know what is this business all about, creating INDSTT chapters where we work and handhold your systems. So with this, I'm coming to the end of my presentation. The concluding remarks are: trenchless technologies offer an effective tool for subsurface construction activities. Due to aging infrastructure and explosive demands, nation will need to develop and enhance its trenchless capacities. Trenchless capacity enhancement needs to address each type of stakeholders involved in the project delivery chain. You have people who are developing the equipment, you have people who are developing the materials, you have people who are developing the cutting tools or operating tools, pipelines, like for rehabilitation, there are special type of pipes which are created. You have data management systems. All those need to be created. And depending on your options, on your choice, you can start working or interacting with such kind of stakeholders, or a complete composite system. The engineering professionals are needed to be cultivated to serve this essential national need. Academic intervention coupled with industrial inputs are essence of this objective. You can create or cultivate vendors in your area who can serve the municipal authority of your area. Just apply the engineering, get the things made by those operators, and those operators become a contractor to civic bodies, and that way some capacity creation will happen. Remember, nation needs to develop its internal capacity for successful subsurface construction projects, and vision documents would play a vital role. INDSTT provides a major platform for such activities and provides necessary knowledge for developing this vision. Underground is future. Let's maximize its potential for our future generations. Thank you very much. This presentation will be available to all of you once I conclude it. So I think my presentation is gone. Now we are on the screen. So let's have some discussion or comments from the audience. Does anybody have any question or wants to have some clarification? No reactions? Everybody has understood everything? If yes, when are we going to start this Trenchless chapter in your college? If you don't react, how would I know? Everybody is mute. Nobody has unmuted yet. Mr. Prag Sharma is saying, "We got it, sir." Nice. But then getting is not the end of it. It's just the beginning.
Yeah, of course.
Thank you very much, Mr. Babu. Thanks for your kind words. See, end of the day, I'm trying to see trenchless technology is the application of several branches of engineering. And I'm trying to bring everything to you that please think about it, and we have to change the course. what we are doing or what we have been teaching boys and girls are routine things. We need to teach them something which can help them to become employable and become asset for the nation. Anurag ji bataiye. Anurag Chaturvedi ji, you're saying something?
Yes, sir. I have one question regarding that. The trenchless, why trenchless technique is not so much popular in India, as it has many more capabilities as per the old techniques, but it is not very popular in the construction activities in India. So why so that?
The reason is we are not teaching our boys and girls properly. So there are risks or there are accidents happening, and people fear that. And they say that, okay, fine, we will go for open cut and do the jobs. But then this ease of working is now getting over. Like you imagine the smart cities being made today. In those smart
Yes.
cities, you cannot excavate all the roads.
Yes, sir.
Can you? So you need
In
to have.
Kanpur city, they have worked under the trenchless cut in the Namami Gange project.
Ji.
But after some time, they went to the open cut method.
You see, UP Jal Nigam has been working with me for time. Whenever they get stuck up, like wherever they have this sand bed, like for an example, in Muradabad, if you are aware, the soil is sandy.
Yes,
And
sir.
creating pipeline below the ground in Muradabad is challenging. So they've
Yes.
been working with me. For Kanpur, they did not come to me. Maybe they did not apply the basic engineering. See, end of the day, if you are having educated boys and girls, only then the project will be successful.
Sir.
And we need to arrest these failures.
Yes, sir.
Ji.
Thank you, sir, for your guidance, sir.
देखिए मैं आप लोगों से why I'm talking is because I want to create these kind of capacities in your boys and girls. ठीक है? If
Yes,
they see what is happening is people simply join an engineering college, study something, and then they go and work for computer science or IT sector. That basically deprives them of deprives nation of those boys and girls. We need to create opportunities which are equally valuable.
Yes, sir. This branch shifting trend is going on these days as the IT sector is booming. Many of civil and mechanical engineers are joining the IT companies.
Yes,
They are not willing to go in the core field job.
exactly. And situation is becoming not very happy because some colleges have stopped admitting core engineering students.
Yes, sir.
So that's basically a sheer very, very major loss, and we need to arrest that.
Yes, sir. There is a big fear in civil and mechanical both branches.
Ji. So we need to help the boys and girls who are in civil, and we need to make them the role models. If they are role models, obviously the things will be much better.
Yes, sir. You are right, sir.
Excuse me, sir.
Yes, Mr.
Sir.
Mr. Harish.
Sir, in many Indian cities and towns, existing wires and cables are overhanging above the ground on the poles.
Ji.
Can all these cables and wires be buried under the ground?
They're being done. They're being done because the overhanging cables result in a huge T&D losses, transmission and distribution losses because of theft, because of the heat losses, because of damages.
Yes,
So,
sir.
so in Delhi, for the last 10, 15 years, all the overhead cables are being moved to the subsurface region.
That is by trenchless technology?
Yeah, it's being done by Trenchless.
Okay, very good.
Yeah.
The same thing should be implemented in other cities,
Yeah,
Indian
it is needed.
cities
So,
and towns.
as faculty members,
Yes, sir.
I beseech you people that please talk to your civic authority people that look here, your cables are hanging. they are hazard,
Sure.
they are creating power losses, and
Aesthetic point of
aesthetically
view
they're
also
bad.
it will improve.
Okay.
Yeah,
So bury them,
correct.
and the savings will come from the heat loss, from the T&D loss. The T&D
Correct.
loss of the energy
Yes,
can be
sir.
saved, and if that is saved, their investment
Correct.
will come out.
Correct. Thank you very much, sir.
Yes, Mr. Jan. Sure. See. So I'm basically proposing to have a partnership between us and your institution. Think about it. Yes, Mr. Gaikwad, tell me. Mr. Gaikwad, your voice is not very clear. Mr. Gaikwad, you have too much noise in your system.
पर लग रहा है कि मिस्टर गायकवाड़ गलती से अनम्यूट हो गए हैं। प्रतिभा, yes, that is fine. And some faculties are raising. Yes, sir. K. Ananda Babu has raised. Sir, please, sir.
Good evening, sir. I am K. Anand Babu from Bhilai Institute of Technology, Raipur city.
Mhm.
And sir, I want to just ask that in Raipur city we have much of traffic, and in coastal areas also we see that there is sandy soil. So there can we apply this type of technique so that
Yeah.
the traffic can also be controlled, and as well as the area where sandy soil is much excess. So how can we deal with such problems, sir?
When I'm talking about sand, what happens is when you're creating a cavity in the sand, the tendency of sand will be to collapse. To prevent that collapse, what you do is you pump in bentonite. There's a clay which is mixed with water, and you make a paste kind of thing. And that bentonite is pumped in. So this bentonite goes and creates a wall of clay in the cavity. And in that cavity which is created, then you pull back or you push the pipe. Generally, you pull back. So this is done in coastal areas or sandy areas. The engineering here is to calculate and evaluate how much clay have to be used and how the pumping is to be done. There are equipment which will be pumping that particular clay, the liquefied bentonite, I should say. So in Raipur also, if you have sandy areas, this is done. I have designed a project in Tiruvananthapuram. In that, there is a Kerala Road Fund project, which was for avoiding the flooding in the area, urban flooding. And that project was done by directional drilling.
Sir, in our city, Raipur, it is not coastal area, but here much of we deal with a lot of traffic, sir. So can we use this particular technique for making underground?
See, what happens is that you will get inside the ground at some location. Do your work, come out at some other location. Your traffic may be moving in between that. You do not disturb your traffic at all.
Yes, sir.
It's a common thing.
Yeah, it will be very helpful if we apply such technique in the highly populated cities.
Yes, exactly. You see, in Mumbai, almost all your drainage lines are being made by, now they have north-south line, east-west line, major upgrade of the subsurface systems is being undertaken. And everything is trenchless.
Yes,
Delhi,
sir.
almost everything is trenchless. Raipur
Yes,
has to come. And one of the vital people would be you people who could work with the ULBs, urban local bodies, that look here, we have this program and you have this requirement. Let's work together. Charge the consulting fee and serve them.
Yes, sir.
When you make a tunnel, what happens to the material that is inside the tunnel? It has to be brought out to the surface, and that will be a problem disposing it off, right?
Yeah, actually, when you are tunneling, you are excavating, and the material is being brought out either through slurry method or through conveyors or through train, what do you call, the boxes on which you fill the excavated material taken out, and then whatever mode it is, then you have to dispose it off either way. Generally, when you are using fluid assisted cutting, that basically means you'll be pumping in bentonite. That bentonite will be allowing the material to float in that bentonite, and that will flow back, or that will be pumped through a pipeline. This goes up. There you separate the bentonite from the excavated material. The separated bentonite is again recirculated in the tunnel. Then the material which is taken out of it by shaking or by doing many of the mechanical means, or by just in settling tank, it is left so it settles down. So that is removed and thrown away. So that is what is the process.
Sir, again, K. Anand Babu.
Yes, Mr. Babu.
How can we make it economical, or we can means present a project before anyone so that this application can be done, sir?
Exactly, that is what the engineering for, and that is
Yes,
that is why you are there and we are there, because there will be many options to do it. Okay, I just gave you three options, three choices here. You can have removal of the excavated material by pneumatic methods, you can have conveyors, or you can have fluid assisted removal. Select something which is the most optimum, and based on that you can give the cheapest possible solution. That is what the engineers are for. Most optimum solution, not cheapest, I should say. Most optimum.
Okay, sir. Thank you, sir.
Ji. So I think, Mr. Mishra, we do have the contact details of all the people who are joining this meeting, and even the more registered people.
Yes, sir. Yes, sir.
So we can talk about creating the Trenchless chapters in their colleges.
Yes, sir.
My proposal.
Yes, sir.
So that way we can have some kind of actions happening at the city level, like this Raipur College. Now,
Yes, sir.
Raipur
Yes.
has, I believe they have a new capital being built near Raipur. So
Yes,
obviously,
sir.
which is a smart city also. So they would need IoT there, they would need the pipelines, they would need the details about it. Let's work together and find out ways and means by which this college can advise the Naya Raipur Development Authority. I believe that is the name,
Yes, sir. NRRDA, sir.
NRRDA.
Yes, sir.
G. So I think interaction थोड़ा बहुत हो गया है.
यस सर. और सर हम जो INSTT का चैप्टर रहता है इंस्टीट्यूशन में,
जी.
वो भी हम शेयर कर देंगे सभी को,
एकदम.
so that any institution or any faculty is interested to establish the students chapter of INSTT in their institution, they may proceed further, and they may proceed for the interaction with you and your staff, sir.
G. Thank you.
Okay, sir. So, sir, with these words, I am again extending my thanks, sincere thanks to you to address this program, to take the session, and as I am receiving the opinion from the faculties, the session is very informative and knowledgeable, sir. And definitely this session will give the new area for their teaching, for their learning and teaching, sir. So, sir, thanks again, sir. Ram, sir.